Today we will learn the problems from exercise 3.4 which are based on the partial fraction. So the first problem, integrate the following with respect to x. So x square plus 2 upon x minus 1 into x plus 2 into x plus 3. So let I is equal to integration of x square plus 2 upon x minus 1 x plus 2 x plus 3. So denominator contains linear and non-repeated factors. So finding the partial fractions, a upon x minus 1 plus b upon x plus 2 plus c upon x plus 3. So after taking the LCM, we get this step. Then x square plus 2 is equal to a into x plus 2 x plus 3 plus b into x minus 1 x plus 3 plus c into x minus 1 x plus 2. Okay, now we will find the values of a, b, c. For them, put x is equal to 1. So 1 square plus 2, and here 1 plus 2 is 3, 1 plus 3 is 4, 1 minus 1 is 0, 1 minus 1 is 0. So in this case, you will get the value of a is equal to 1 by 4. Similarly, put x is equal to minus 2. So after putting minus 2, this factor becomes 0. This factor also becomes 0. So in this case, you will get the value of b, that is minus 2. Similarly, now in next step, we will put x is equal to minus 3. So this factor will become 0. So a into 0 is 0. This factor also becomes 0. So b into 0 is 0. Okay, so x is equal to minus 3, therefore minus 3 square plus 2 is equal to c into minus 4 minus 1. So c is equal to 11 by 4. So by this way we have find out all the values of a, b, c. Now we will put that values in our partial fraction, so we get this step. Now instead of integrating this function, we will integrate this function. 1 by 4 is a constant, we can take outside. Minus 2 is also constant, we can take outside. 11 by 4 is also constant, so we can also take it outside. 1 upon x minus 1, its integral is log of x minus 1. 1 upon x plus 2, its integral is log of x plus 2. 1 upon x plus 3, its integral is log of x plus 3. Okay, so this is the integration of the given function. You may simplify it or you can keep as it is. This is the next problem. Here each of this term contains x square. So for finding the partial fraction here, we will only for finding the partial fraction, we will replace x square by t. Then we get the partial fractions like this: a upon t plus 1 plus b upon t minus 2 and plus c upon t minus 3, because each of these is a linear non-repeated factors. So take the LCM, you will get the equation. In this equation, we will put step by step t is equal to minus 1. After putting t is equal to minus 1, evaluate the value of a. Then we will put t is equal to 2, x is equal to, no, sorry, t is equal to 2. In this case, our partial fractions are in the variable t. So we will put t is equal to 2. Then in next step we will put t is equal to 3, so that these two factors will become 0 and you will get value of c. So these are the required partial fractions of the given function. Now we, for time being, we have replaced x square by t, so again we will put that value of x square here. Okay, and then instead of integrating this, we will integrate this part. So 1 upon x square plus a square, its integral is 1 upon a tan inverse of x by a. Here 1 upon x square minus a square, its integral is 1 upon 2a log of x minus a upon x plus a. And here it is 1 upon a tan inverse of x by a plus c. So multiply this and multiply and simplify. what you will get? This is the solution of this second problem. Now 12x plus 3 upon 6x square plus 13x minus 63. This is our problem. So in denominator doesn't contains any factors, so we have to, first of all, it is we have to factorize the denominator. You will get the two factors, 2x plus 9 and 3x minus 7. Now we will use partial fractions for this integrand. A upon 2x plus 9 plus b upon 3x minus 7. So put x is equal to minus 9 by 2 so that it becomes 0 and you will get the value of a. Similarly, put x is equal to 7 by 3. Then we will obtain, after putting 7 by 3, 12 into 7 by 3 plus 3 is equal to a into 3 into 7 by 3. So the 3 will get cancelled. 7 minus 7 becomes 0. So a into 0 and b into 2 times 7 by 3 plus 9. So in this case, you will obtain the value of b. Now use this a and b in this partial fraction. Okay. So 102 upon 41 divided by 2x plus 9 plus 93 upon 41 divided by 3x minus 7. So this is the integrand. Take the integral 1 upon ax plus b. Its integral is log of ax plus b upon a. Here also the same formula we will use. Then divide this 102 by this 2. Then divide 93 by 3. You will get 1 by 41 common. So 51 log of 2x plus 9 plus 31 log of 3x minus 7 plus c is the solution of this given problem. Now the fourth one example, 2x upon 4 minus 3x minus x square dx. Okay, so how to write it? We can write it as 4 minus 4x minus 6 minus x square. So we are factorizing it and we are finding the factors, 1 minus x, 4 minus x. So now use the partial fraction, a upon the first factor and b upon the second factor. So here each of these factors are non-repeated, linear and non-repeated. So use simplification. Now we will put x is equal to 1 to find the value of a and x is equal to minus 4 to find the value of b in this, from this equation. Now we'll put these two values in this equation. So 2x upon 1 minus x into 4 plus x is equal to 2 by 5 upon 1 minus x plus minus 8 by 5 upon 4 plus x. So 2 upon 5 into integral of 1 upon 1 minus 6 dx minus 8 by 5 integral of 1 upon 4 plus x dx. So integration of this is 1 log of modulus of 1 minus x upon coefficient of x is minus 1. Here log of 4 plus x and the coefficient of x is 1, so no need to write. So the integral is minus 2 by 5 log of modulus of 1 minus x plus 4 times log of modulus of 4 plus x plus c. Now equation number 5, problem number 5. Here it is clearly this is not a proper rational function. Why? Because the degree of the numerator is more than the degree of the denominator. So we have to divide the numerator by this denominator. We have to actually divide the numerator by the denominator. So how to divide? This is the procedure to divide this numerator by this denominator. Here 3x square, here is 6x cube. So by which factor we have to multiply to this 3x square so that I will obtain 6x cube? Obviously 2x. So 2x into 3x square 6x cube, 2x into minus 2x minus 4x square, 2x into minus 1 is minus 2x. Then subtraction, take their subtraction, we will obtain this. Now here is 9x square, again now here is 3x, so only 3, so plus 3. Then multiply this by plus 3, you will get this equation. Take their subtraction again. So after taking the subtraction, you will get 8x minus 4. So we can write this numerator using this quotient, dividend and remainder. 3x square minus 2x minus 1 into 2x plus 3 plus 8x minus 4. So now divide this denominator separately. Then integration of 2x plus integration of 3 plus integration of this. Okay. So after simplifying, call this integral to be I1. Okay. Then we will solve this integral by our usual method. 2x minus 1 upon 3x square minus 2x minus 1 can be factorized by like this. So we can use the partial fraction a upon x minus 1 plus b upon 3x plus 1. So cross multiply and simplify, you get 2x minus 1 is equal to a into 3x plus 1 plus b into x minus 1. Put x is equal to 1 so that you will get the value of a, and then we will put x is equal to minus 1 upon 3 so that we will obtain the value of b. Then the partial fractions are as this. Now we integrate this with respect to x. 1 upon x minus 1 is integral is log of x minus 1, and 1 upon 3x plus 1 is integral is log of 3x plus 1 upon 3. Take 1 upon 4 common, or you can keep it as it is. So now using this I1 in our equation number 1, where this we have to multiply it by 4. So 4 will get cancelled, and what will remain? Log of x minus 1 plus 5 upon 3 log of 3x plus 1 plus 4 times c1, but 4 times c1 is replaced by another constant of integration c. Now here both numerator and denominator both are having the same degrees. So again here they are not in the function is not a proper rational form. So we have to do, actually we will divide the numerator by the denominator, or if it's possible we will adjust the denominator in numerator. Here it is possible to adjust the denominator in the numerator by adding and subtracting plus 5. So x square plus x minus 6 plus 5 upon x square plus x minus 6. So separately divide, you will get 1 dx plus 5 times this 1 upon x plus 3 x minus 2. So for this integral we will apply the partial fraction a upon one factor plus b upon another factor. Then the values of a is minus 1 upon 5 and values of b is 1 upon 5. Now how I have obtained this I will explain here. Now to find the value of a, what is the denominator of a? It is x plus 3. It becomes 0 when x is equal to minus 3. So what I will do, I will put x is equal to minus 3 in the remaining part. So a is equal to 1 upon minus 3 minus 2 is equal to minus 1 upon 5. Okay. Similarly, for finding the value of b, I will put x is equal to 2 in this part. So b is equal to 1 upon 2 plus 3, that means 1 upon 5. So 1 upon x plus 3 into x minus 2 is equal to minus 1 upon 5 x plus 3 plus 1 upon 5 x minus 2. Minus 1 upon 5 integral of 1 upon x plus 3 dx plus 1 upon 5 integral of 1 upon x minus 2. Here the integral is log of x plus 3, and here it is log of x minus 2. We can take 1 upon 5 common and we can combine these. So I can write it as 1 upon 5 log of x minus 2 upon x plus 3 plus c1. Okay, now we will put this I1 in equation number 1. So x plus log of x minus 2 upon x plus 3 plus c, where c is equal to 5c1. Now look at this example. Here 4x square minus 1 is written. So I can write this 4x square as 2x bracket square. Then it is a square minus b square. So a minus b, a plus b. Then we will use here to each of this factor is a non-repeated linear factor. So use the partial fraction a upon 2x minus 1 plus b upon 2x plus 1 plus c upon x plus 3. Now how to find the constants? Just now I explained. I have used the same method here to find the value of a when its denominator becomes 0 by putting x is equal to 1 upon 2. So what I will do, I will put x is equal to 1 upon 2 in the remaining part so that I will obtain the value of a. That's it. Okay. Now to find the value of b, when this it becomes 0, when x is equal to minus 1 upon 2. So what I will do, I will put x is equal to minus 1 upon 2 in this factor. So I will obtain the value of b. Similarly, to obtain the value of c, I will put x is equal to minus 3 in the remaining part. So we obtain the partial fraction as this. Integrate with respect to x. So minus log of 2x minus 1 upon 2 plus log of 2x plus 1 upon 2 plus log of x plus 3. Okay, so minus, we can take 1 upon 2 common from these two. So log of 2x plus 1 upon 2x minus 1 plus 3 times log of x plus 3 plus c. Now look at this example. 1 upon x into x raised to 5 plus 1. Now so as it is x raised to 5, so how to use the partial fraction here? So it is not possible to use the partial fraction. So basically you have to use substitution here. But for substitution, we must have the derivative of the function of which we are substituting. So first of all, we have to multiply divided by x raised to 4. So it becomes denominator contains x raised to 5. Then we will use the substitution x raised to 5 is equal to t. So 5x raised to 4 dx is dt. That is x raised to 4 dx is dt upon 5. So we converted the integral in the simplest form, 1 upon t into t plus 1 dt by 5. Now you can use the partial fraction here. I am directly simplifying it. I am directly writing it 1 upon t minus 1 upon t plus 1. If you cross multiply, you will get this same expression again. Separate the integral and evaluate it. Log of t minus log of t plus 1. That means log of t upon t plus 1 plus c. Okay. So 1 upon 5 times log of x raised to 5 upon x raised to 5 plus 1 plus c is the integral of this given function. Now, this is the ninth example, and the example is simple. In denominator, we have to write x square and x square. Okay, so everywhere, if you see, you will see the x square. Powers of x is x 2 only. So for finding the partial fractions in this case, we will replace the x square by t. Then simplify it, you will get the value of a. Now how to find the value of a? The denominator a becomes 0 when t is equal to minus 4. So we will put minus 4 in this part. Okay, and for t is equal to minus 5 to find the value of b. Okay, so the partial fractions are 2x square minus 1 upon x square plus 1. These are the partial fractions. So integrate this equation. 1 upon x square plus a square, its integral is 1 upon 2 tan inverse of x by a. And here also the same integral we will use, the same formula we are going to use, minus 9 by 2 tan inverse of x by 2 plus 11 by root 5 tan inverse of x by root 5 plus c. The 10th example, here also the each power of x square is x is a 2, so we will replace x square by t only up to finding the partial fractions. Okay, we as usual find this values of a. Okay, then the partial fractions you got minus 4 upon x square minus 1 plus 5 upon x square minus 2. Integrate these partial fractions and use the formula 1 upon x square minus a square is 1 upon 2a log of x minus a upon x plus a. So 5 upon 2 root 2 log of x minus root 2 upon x plus root 2 minus 2 log of x minus 1 upon x plus 1 plus c. Now 2x upon 2 plus x square upon 3 plus x square. If you see, the derivative of x square is a 2x is present in the numerator. So here definitely we will use the substitution. X square is equal to t, so 2x dx is dt. So we got the simplest partial fraction here. 1 upon 2 plus t into 3 plus t is equal to a upon 2 plus t plus b upon 3 plus t. So a is 1 upon 3 plus t to the where we want to find the value of a, so we will put t is equal to minus 2 in this part. Okay, and to find the value of b we will put t is equal to minus 3 in this part. So these are the values of a and b. So put that values here and then integrate 1 upon ax plus b. Its integral is log of ax plus b, log of 2 plus t, and here log of 3 plus t. So take the division. I is equal to log of 2 plus t upon 3 plus t plus c. Therefore, I is equal to log of 2 plus x square upon 3 plus x square plus c is the integral of this function. Okay, so we will stop here. In next lecture again, we will continue our same exercise 3.4.